log. It's better than bad. It's good. You're gonna love a log. Everyone loves logs.
Sounds like my studies.
Anyway, so logarithms. What's 2 squared?
Cheerleader log.
Oh. Excuse me. What's 2 cubed? Okay. 2 to what power is 6 then?
2.5.
That's why you need logarithms. Logarithms work with bases and what are called exponents. Logarithms. Equations log, it's called log of a base b of y equals x, which means the same thing as, that means a double arrow, it's kind of bad, as b to the x equals y. So what happened here is, I can take what's called a base. Logarithms have different bases. That's why it says log base b. And then on the other side, see how I wrote it as b to the x? Well, base raised to an exponent. These two values are completely equivalent. They mean the exact same thing. So if I go back and think of the idea of, what was it, 2 cubed equals 8. What that means then is that a log of base 2 of 8 equals 3. What we're doing here is we're rewriting something between what's called an exponential form and logarithmic form. Otherwise known as log form. Logarithmic, I could probably spell that, but it just seems like it takes too long. So what we have here is that using what are called logarithms, logarithms are going to allow you to solve for different exponents using different base values. A lot of this stuff today, what we're going to do is work with values that are going to be very easy. It's a lot of these things can be done without calculators. Your calculator does have ability to change, do a log base. You can change the different bases and do all kind of stuff. There are problems if you think about when you have interest things. You know how we had, excuse me. You know how if you wanted to figure out $10,000 or $1,000, if you deposited $750 at 1 plus 0.15%, at what rate would you have to get? This is how you can solve for an exponent. If you ever had an unknown variable as an exponent, logarithms are what allow you to do that. That's why they're there, okay? And we'll get to being able to solve this equation eventually, but that's why we have logarithms, to solve for exponents. Real simple. If you think of this, what is, well, help me write this out. What is 2 to the 0 power? 1. Anything to the 0 power is always 1. Now, if I think of this in terms of log form, exponent form, that means that the log of base 2 of 1 is 0. Okay. What I want you to see here is that this value is called a base, and this value is a base. This is your exponent, which when you write out log form, this is also your exponent. That's how you get your exponents to fall, using log-based stuff. Excuse me. It also works the same way. And these are, remember how I said that we do graphing with logarithms? And I think I might have mentioned that when you graph with logarithms, you're only going to need to know 2 points. Like when we graphed with E, all we needed to know was the intercept and our asymptote. eventually when we talk about graphing, we're gonna do the same thing with logarithms. We're gonna graph using these two properties. Log base b of 1 is 0, and base b of b is 1. Because of the reciprocal properties, but because of the properties of anything raised to the first power is itself. So 2 to the first power is 2, 7 to the first power is 7, and so on and so on. That's how we're going to be able to graph logarithms tomorrow. They're going to have a common shape to them, but all we need to have are 2 points on a graph to know which direction things are moving. Okay. The rest of the logarithm values for in tables, forming, and stuff like that are real nasty to work with. So you have these two basic properties. I'll write it out this way. So then we also had 2 to the first power is 2 because log base 2 of 2 is 1. Two main properties of logarithms. Well, first, log base b of y is x, which means b to the x, y. Because of those. As you start to see a couple of these things with numbers, it works out. You'll see how things work out real quick. Because if you have the same base, that's why it becomes 1. So let's do some examples. Rewriting things from log form to exponential form. It's kind of one of the quick things to work with because this will help us probably later half of beginning of next week, excuse me, as far as solving equations. So if we understand how to rewrite things in terms from log form to exponential form, how they work back and forth becomes super easy. So if I have log base 2 of 32 equals 5, when I rewrite it from log form to exponential form, that means it's going to be 2 to what power? Equals 2 to the 5th is 32. Okay. Log base 5 of 1 equals 0 means what?
5 to the 0 equals 1.
Very good. Good support there. Encouragement. Log base 10 of 10. 10 to the what? Yeah. 10 to the 1 is 1. And now it starts to get a little dicey. Negative exponents. Now think of this one. Log base 10 of 0.1. Yeah, because what's 0.1? It's 1/10. So sometimes you'll see it written as 0.1, sometimes you might see it as 1/10. So that just means that 10 to the negative 1 is that, or 1/10. It happens a lot in textbooks and stuff that they will switch between decimal values and fractional values. Remember your exponent rules. When you have negative exponent, it just means you're flipping it. Okay? It just means you're flipping it. Log base 1/2 of 2 is negative 1.
Negative exponent. Do you multiply it first and then flip it?
What do you mean?
Like if you have like 2 to the negative third, would you do like 6 over 1 and then flip it to? I mean, wait, that's not 6. It's 2 to the third power. 8.
Powder?
Would you do 2 to the third?
You can do either one. Personally, what I would do is I'd flip it first. That way I don't actually write 2 as just 8 and just leave it.
So you would do 1/2 to the third first?
Yes, because because your denominator here is 1, so yes, when you flip it. Now, if this was the quantity 2/3, then I'd have a 3 up top that'd have to be cubed as well, and I'd get 27 over 8. See what I'm saying? Your best bet is always to make your exponents positive first before you do anything else. That's all. I think that's where you're good.
Yeah. I didn't know if you were supposed to like do the exponent rule first and then like try to flip it, but then it was like I was
Use your exponents. Do your exponents first.
Because you get 2 hours of sleep every hour.
And then lastly, it was 1/2 to the -1 is 2. Because then that's just your exponent rule again. 1/2 to the -1 power just means you reciprocal it, and you get 2 over 1. And again, it just stems back and forth between your log base b of y is x, b to the x is y. That's how they just go back and forth with one another. Okay. I do apologize for when you guys get the pre-calc. They write it as log base b of x equals y, and b of the y equals x. They flip-flop x's and y's. I don't know why. I apologize for next year. But you'll probably forget, so that's okay.
Yep. I don't remember I had to practice.
Rewrite the, we just did this. Take a minute, we got time. Well, the post downstairs was over your neighbor's stuff. It's 5th grade stuff. It's a new bag. It's blah, blah, blah. You guys could have been at least somewhat enjoyable for that. Can't believe none of you like it.
I've heard that before. I don't know where, but that's pretty stupid.
Sorry. Can't be the most awesome thing in the world for you every day.
True.
I try to shed a little bit of light in the dreariness of the middle of February.
I don't see why you had like, that's like as good as having like a pet rock.
Pet rocks were all the rage, man. They were.
They're not real.
They're rocks. How are rocks not real?
They're rocks.
Okay. But don't rocks have molecules and bits and pieces to them?
I don't know.
You're not a
I've never had
geologist?
a pet
You never had a rock?
rock. Never had a pet rock.
When's your birthday?
May.
Sweet! Ladies and gentlemen, Pete Meyer's birthday's coming up. We're all going to get him a rock.
it's within
Throw it
the
out.
May.
May 32nd.
Which means
It's not your
May-
That's not even a day.
May-
Birthday.
You don't
May-
know my birthday. Don't even talk
Bet
to me.
it's May 13th.
No, it's not.
It is.
Pete Meyer, guess what? I have this thing called Skyward. I can figure it out.
Isn't it? It's May 13th.
No, it's not.
So we're all bringing rocks for Pete Meyer's birthday. I'll make sure I'll send you out a reminder email. So first one is what? Rewrite an exponent form.
Showed up to school and literally everybody cried.
I will.
Next one.
Like you just walked in and
Next one. Last but not least. So at first you guys were like, oh, what? Logs are pretty easy.
you can't keep your birthday.
Rocks are hard. Oh no! Oh no! Oh no! Oh no! Log base 9 of x equals 1/2.
3.
Very good. Rewrite it in terms of exponential form. This means 9 to the 1/2 is x. What does a 1/2 power mean? Square root. Square root of 9 is 3. Solving very simple equations using logarithms. Solving very simple equations using logarithms. All we had to do is rewrite into exponential form, and you're able to get the x value by itself. Log base 3 of 81 is going to equal what? Log base 3 of 81 is going to equal what? What I want you to do is think of it this way. This is going to equal x. 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 That means 3 to what power is 81. Well, what's 3 squared? Oh. See, and that's what you're doing. You're trying the values that they're going to give you are going to be ones such that you're not going to need to use your calculator. You shouldn't need a calculator. Okay? So 3 to what power is 81? 3 to the 4th power. Oops. Okay. 5 to what power is 0.04? Well, that stinks. That's 0.04. So let's think of that in terms of a fraction. That's 4 100ths, otherwise known as 1/25. 5 to what power? 5 to what power is going to be 1/25? Well, 5 to the negative 2 equals 1/25. So x is negative 2. When you see decimals, rewrite them as the fractional counterpart, and you're going to get stuff that'll work with. Same deal going the opposite direction. 1/2 to what power is going to have to equal 8? Which means if you're going from a fraction to an integer, you probably had to use a negative exponent, which is negative 3. Very good. So little trick here is that if you're starting with your base as an integer, and then you're going to a fraction or a decimal digit, you had to have a negative exponent. Same deal going the other way. If you start with a negative base, and you're going to an integer, you also had to have a negative exponent. It's little tricks like that you'll pick up on. Which means here this one was x in the, this has to be negative 3. And then last but not least, 9 to what power is 3? Or 1/2, good. That's not too hard on the brain, is it? All right, bells and rings, so do, where's my day 1? Oh, I did write down day 1. Ooh.
You don't need to give us.
Yeah, I did. Haha, it's funny.
You don't need to give
Get
us.
my paper, I want to do day 1.
Come on, Val, don't do this, Val.
No, it's 2 days. Day
No.
1, day 2. Day 1.
You will not have homework. Come
You
on.
will have homework.
I believe in you,
Well,
Val.
just email it to us and
No.
Release
This
me.
kid sat there and say, oh, I didn't get my email.
Release me, Val. Yes! No! There's no
490.
There's no homework.
I can't see board.
16 through, what
See
is
ya,
that?
there's no homework.
35 all. And then 48 through 55. These are all real quick. This is 8.4.
Dang it,
All right.
Zach did well. He said he's not doing it.
Number real quick.